Jai Hind, good morning, good afternoon, good evening to all my students, the people who are seeing this video. This is the 7th lecture of this series of Industrial Engineering. Subject code is KME 503 and it is for BTech Mechanical Engineering 3rd year 5th semester. And this basically will talk about facility location and plant layouts, right? So we have covered lots of things before this video. You can please go through the previous videos also so that we can connect with those videos and then we can come to this video, right? So this is unit 1 lecture 7. So this unit 1 lecture 7 will talk about facility location and plant layout. The topics that we'll cover here is principle of plant layout design and types of plant layout, right? And these two things will start, and then we'll be talking about the principles that we basically take care of when I talk about a plant layout design. In the previous lecture, we talked about factors affecting facility location, and we've also solved a problem which basically helps us to understand how a facility location can be decided, where we are going to establish a facility, how we'll basically plan it. That is in the lecture number 6. So this is lecture number 7, and here we are actually talking about the layout design. Now always remember, this is also a long-term planning, and this is a strategic planning that will be carried out in a long term also. So whatever we plan it here should be a thing that can be taken forward in the future also, right? So the principles of plant layout design, if I really talk about it, it is the facility layout problem is a multi-criteria problem. Numerous factors such as location and work centers, offices, computer center, design and drawing sections, tool room, storage space, utilities, and if you really see, etc., are to be considered. The principles of good facility layout involves, there are four things that we must take care when we actually talk about a plant layout design, and it is definitely a multi-criteria problem where we have to see to it that the other aspects and the machine locations, the way we place the machines, the way we produce the products are to be looked into, where we are into the smooth production system. And this is a part that basically relates us with the production system that we have read in the previous lectures. And these are 4 principles that we will talk in details also in the coming slides. The first one is least material handling cost. Second one is worker effectiveness. Third one is high productivity and effectiveness. And fourth one is group technology. So these are the points that we will see, and we'll see how these principles are used whenever I want to design a plant layout, right? When I want to design a plant layout, these are basic principles that we have to take care of, and we basically implement that in the design process. So the first is the principle of least material handling. For less material handling, following approaches are adopted. The approaches are place facilities as per sequence of part operation. So when I really see it, we'll see that we have to place the facilities as per the sequence of the operation. Then we come for proper location and store and packaging of area. Then we go for smooth and continuous flow of material. Then we go for utilization of vertical space, height in material transport. So these are the points that we have to see to it whenever I design a material handling system. In the process, I have to make sure that the layout should be designed in such a way that the material handling is as less as possible, right? The material handling is a thing that basically involves lots of time and also cost. So we basically understand one fact that if the material handling is lesser, then the time is saved, the money is also saved. So place the facilities as per the sequence of the part operation. Proper location of store and packaging area, smooth and continuous flow of the materials is very important, and then utilization of vertical space and transport. So this is something that we have to see it when I talk about any plant layout design, right? The second thing that comes is the principle of worker effectiveness, right? Now effectiveness, if I really see, effectiveness is nothing but a very the performance factor that works out here, that how much effectively we are doing this job, right? So we have read about effectiveness in the previous slides, in the previous video lectures. So now we can relate that effectiveness here also in the plant layout design. For better worker effectiveness, following approaches are adopted, right? If I really see the adopted, the concept that we actually talk about here is, just wait, I'll just open the pen and we'll see how the things actually works out here. The integration of similar facilities at same location, right? So if I really see, the worker effectiveness can only come up with the few changes that are required, right? I know that the effectiveness can be imbibed with the motivation also, but from the system parameters, if I really see, I see that integration of similar facilities at same location, like all milling machines may be placed at the same location, right? So all the milling machine, the operators of milling machines are staying together. So their work will basically give a better output when you actually place them together, right? Sufficient space for workers for movement, sufficient space for the movement of the material between machines, and safe working environment. So these are the basic points when I actually talk about worker effectiveness in this case, right? Workers are to be effectively used in the system so that their performance is high. Now we talk about principle of productivity, high productivity. Now we see that this is also another point. This is the third point. Here we see that for high productivity and effectiveness, the following approaches are adopted. The first one is flexibility to expand, rerouting, varied products mix, etc. So one thing is very important in the case of plant layout is that there is a fear of obsolescence. So if we do a layout in such a way that tomorrow, if the product changes, we cannot actually have the changes that can be done in the layout. So once we do that process, we have to see to it that the flexibility to expand is very important. The flexibility of rerouting is important, and flexibility of varied product mix is also very important. So we have to see to it that if tomorrow the product variety changes, then we can easily accommodate that into our plant layout. If the routing is not rightly happening, so we have to also see that the routing can be rerouted if required, right? And then there must be a flexibility to expand the plant if required, right? So all the options are to be kept in mind when designing a plant layout, right? Now, the second point in this case of principle of high productivity is scope to use multi-skilled workers. And then the last one is proper utilization or over utilization aspect that we basically see when I talk about this is proper utilization or over utilization of the resources, etc. So we can use the facilities that we have, the resources that we have rightly, so that the productivity is rightly produced. And this is the last principle of plant layout design. This last principle talks about principle of group technology. Now, for deriving the group technology benefits, following approaches are adopted. First one is group similars in one part. For each part family, design a machine cell. Machine cell is a combination of machines which caters to all the processing requirements of the corresponding part family as far as possible, and minimize the inter-cell transfer paths. So this is the concept that basically talks about grouping the machines rightly, right? Grouping the machines so that there is minimum time between the movement. The material transfer movement is as minimum as possible. So if I really say this, this is basically grouping similar parts, group similar parts in one family. And then this is a concept of group technology as a whole. If I talk about group technology, we have got the concept that basically divides or separates the parts from one another depending on the part family. Like if I talk about a part that is a cylindrical part, then the operations that will be done in that cylindrical part is mostly in the lathe machine. So this way we can make a family of the parts which are actually having cylindrical shape, and then there is a turning operation required where the job rotates. So this is a family that you can make, and we have got different codes for that. So group technology basically helps us to understand that the types of machines are to be kept in the same place, and that is what they say, that we have to make a machine cell in this case, where we actually place a product and manufacture it from that machine cell, right? It's a combination of machines which caters to all the processing requirements of the corresponding part family. Now, as far as possible, minimize the inter-cell transfer. So, inter-cell transfer is also not required. We must minimize this. We must minimize this rightly so that the time in between the transfer is not wasted, right? So, here we generally talk, and when you talk about this group technology, there is a concept of line balancing. We'll talk about this in the coming videos. There's a concept of line balancing. When I talk about line balancing, I basically talk about making a number of operations into a cell, and then these cells are actually planned in such a way that is with the precedence diagram and a whole lot of concepts comes in when I talk about line balancing. And then I make sure there is no balance delay. There are the efficiency is higher, the smoothing is higher. So, these are the concepts that we will talk in the line balancing whenever we come to this lecture. In the coming videos, we will see about how we can plan a line balancing problem. So, like this we can use this group technology concept. Now, we come to layouts, the types of layouts. So, today we will be talking about product or line layout, and there are actually 4 types of layouts that we will be discussing in this video, in this lecture series. So, first today we will only talk about the first one, which is product or line layout. So, we have got 4 types of, commonly 4 types of plant layouts, and these are all connected with the production systems. When I talked about production systems, you must remember that we talked about different types of production systems, and then those production systems are basically accommodated in the plant layout. So, the type of production system required, and then the plant layout is defined as according to that. So, we have got 4 types of plant layouts. These are product or line layout. The second is process or functional layout. The third one is fixed position layout, and the fourth one is cellular or group technology layout. So, this group technology plays a very important role. So, I advise you to also go through some literature on group technology, so that we can see that very rightly. So, product or line layout. When I talk about product and line layout, it is in a product or line layout, various facilities such as machine is there, equipments are there, workforce is there, etc. are located as per the sequence of the operation of the parts. Even if a facility or a machine is needed, again after few others operations, we duplicate the facility at every required sequence. Product layout is preferred when production is continuous, part variety is less, production volume is high, and part demand is relatively stable. Now, if I really see, then this is a requirement that basically talks about mass production. It talks about mass production, right? And if I see this is talks about mass production or say continuous production also, but more of mass production, continuous production. So, when I really see this, so we have got two things that we basically see here is, one is we are catering the mass production, or we are also catering the continuous production. So, here what generally concept is, the product is the leader, like the product defines everything. Now, products is supreme. In this case, if I really say, if I talk about product layout, I must say that product is supreme, right? The product is supreme. The product is supreme. Now, if the product is supreme, the product defines how I will place my machines and how the system will work out. They also say that if the product needs the operation or same operation after say 5 operations are over, so we have to place a machine after those 5 operations, the same machine can be put again. So, the product movement should not get disturbed in the case of product layout. When I talk about product layout, I talk about the product which is supreme and it defines the rules, and this is implemented when it is a mass production, where I know that the product is going to be in the market, and I place my I plan my layout in such a way that the product can be manufactured with lots of ease. There is no time wastage, there is no material wastage, and things gets into right process. So, we will see how a product layout looks and what are the various reasons we do this product layout and how to do it, right? So, now a product layout basically looks like this. If I really see a product layout, it basically looks like this, where I have got 2 products, say I have got 2 products. Now, this is product B, this is product A, right? if I have got this product A, so if I see this L is lathe, D is drilling, M is milling, and G is grinding. So I have seen that L is lathe. So the product must be having some operations in the lathe machine, and then the product will go to milling machine, and again it will go for lathe, and then again drilling, and then for grinding, right? So if I really see, like a product basically needs something on the lathe machine, and then it goes to milling machine for some operation, then again it has to go for lathe machine. So depending on this product, if I see the product should move from this direction to this direction, right? Now product needs milling, it should not come back to lathe again. After milling, if it needs lathe operation lathe, it should not come back, it should move forward, and then we have to place another lathe here. So depending on the product, now the product A defines this layout, right? The product A defines this layout. Now product B defines this layout, say milling, drilling, and grinding. So the product B defines this layout, product A defines this layout. So we have to see to it that the products are supreme and they basically define the layouts. So it's very easy, but it is one of the layouts that basically is a layout that is always in problem. If suppose tomorrow the variety of the product changes and the product line changes, then the total layout goes haywire, right? We have to change the layout, and that is a very costly process. Advantages of product layout, if I really see, it is less work in process, WIP inventory, as the flow of the material is continuous along a line compared to process layout. Now we'll talk about process layout, right? We'll talk about process layout. We have not talked about process layout, but we have to see to it that in comparison of the next layout that we'll talk, it requires less space for same volume of production. It is conveyorized material handling or automation in the material handling is cost effective. Material handling is cost effective as the flow of the material is well known. The throughput time of the product cycle time is less compared to process layout. This is due to the chances of congestion and less waiting time of the machine. So we have to understand first one is the WIP is less because there is no work in process, because all the machines are in line and there is no time losses in between. Compared to the process, it requires less space. Also requires less space because we are not keeping it in a group of machines. We are just keeping it as the product is required. So the space of the same volume requires less space also. It is conveyorized material handling or the automation in the material handling is cost effective as the flow of the material is well known. So I know the material flow. So it is easy for me to make sure that the flow is rightly done. And then the throughput time is less compared to the process layout. This is due to the less chances of congestion and less waiting time in the machine. So here in this case, there is no delay. Because we have to see to it that the machines are, the processes are rightly done, and the machines, the product does not wait for the machines actually. The machine is ready before the previous product operation is over. So the congestion time is less, the movement of the material is easy, and it becomes a very helpful type of layout when I talk about mass production. When there is a mass production, this is very helpful, right? So fifth point is simple production planning and control and better coordination of different varieties may be achieved. The skill level of the workers may be less. This is something that we'll talk later, as a particular worker has to do a particular operation which seldomly changes due to standardized production line. The flow of material is smooth and continuous. So we have to always see one thing in this type of layout. When I talk about product layout, is that the skill of the workers, we already talked about it when we talked about mass production. So if I talk about the plant layout, the product layout, we see that the skill of workers is lesser in this case, because has to do a particular operation which essentially changes to the standards operation. So we have to see to it that the labor, basically a very skilled labor, is not very much required because he has to do the same job every day, right? So when he is doing the same job, so he can learn his skills or he can get these skills while working. So very high skilled people are not required in this case. So that is what is told here, and then we have to see to it that if the layout is a product layout, the workers skill level is not very highly required. So you can see that this works with simple production planning and control, and better coordination of different activities may be achieved. The flow of material is smooth and continuous. So this is something that is also very good. So it's a easy way of producing a product because I know the product. I don't have any risk of changing the products, right? So when I know that the product is going to run in the market, so I will make a layout that is basically a product layout. Right? Now, limitations of product layout is change in product design is difficult to accommodate. Now, this is very important that we cannot change the product design because my product is same, the operations are defined, the process plan is defined. So when the process plan is defined, I know which are the machines that this product will go through, and when this is clear, then I can understand that this product is moving from this machine to this machine. The operations are already. So no product changes is allowed, and it is difficult to accommodate if I really want to change the operations in between because the machines are all fixed there, and it takes time. If you really see establish or a fixing of the machine takes time. Product variety is very much limited. The variety, we don't talk about variety when I talk about plant product layout. When I talk about mass production, breakdown of a particular machine. This is a very important fact. A breakdown of a particular machines in the line halts the production output. So one machine gone, the production stops. So we have to make sure that the maintenance of the machines are very rightly done. There we have must check that the machines are rightly maintained and they are working in the working condition in all the times, right? And then the capital investment in machines may be higher as compared to process layout, and duplication of the machines in the line may be needed. So this is very clear. We have already seen that the capital investment is required because we have to take number of machines, same variety of machines for the production, right? Because it's a mass production, so we cannot take any risk here, right? And then the flexibility to increase the production capacities is limited. So the production capacities is also something that we should talk about when we talk about the limitations, is that the capacities cannot be increased because everything is well established, and we know that this much output I want from this plant. So like if I see about Maruti Udyog Limited, they know that this plant is manufacturing say 50 vehicles today. So that way we cannot increase the productivity in that line, and we have to create a new setup for that. So always remember, the capacities are limited. We cannot increase the capacities because we are taking up the 100% output of the system, and we know that this much you can produce. So if I really wanted to produce more, I have got more demand in the market, I have to set up a different setup also, layout also, right? So suitability of product layout is assembly lines such as automobile factory. So this is very important, that where we are using this product layout. If I really see the product layouts we are using in assembly line of lines such as automobile industry factory, low variety, high volume production system for standardized products which have quite stable demand in near future. So there are three aspects that you can see it here. Is assembly line such as automobile. So all the automobile products or the cars that we are seeing here, all is a output from a product layout. So it is actually a mass production, and then we can prepare it there. It's a low variety, high volume production system. So variety is less, volume is very high. So it's basically a mass production. For standardized products which have quite stable demand in near future. So we know the demand is stable, so we can always fix it up and we can easily produce the output here. So I think this is something that is very, very important, and this is the first type of layout that we have talked in this video. And I would request you all to read the book that I have already told. It is Industrial Management by Dr. Ravi Shankar, and this text and all the inputs are taken from that book with other inputs from other books also. So I think I've clearly told about the types of product layouts, and then we'll talk about the next layout, that is process layout, in our next video. I think I will end my video lecture here. Thank you so much for watching. Please subscribe to this Ajay Kumar Garg Engineering College YouTube channel so that you can be connected with us, and feel free to write any comment in the comment box. Any questions that you have, please write it down. We'll be happy to answer you. Thank you so much. Jai Hind.